Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey. Hi everyone, today we're going to talk about probability. We're going to talk only about the basic probability since this is intended for grade 7 students. First, we're going to define probability and basic terminologies in probability and solve problems involving simple probability. So let's start. Let's start with a question. What do you think is the chance that a random stranger will order a regular burger, a fries, and a soda from the menu? Below are the choices. So basically, the menu is consisting of burgers, side dish, and drinks. So we have 3 choices for the burger, 3 choices for the side dishes, and 2 choices for the drinks. So if we are going to do that, let's create first a tree diagram. To form a meal, we have to order a burger, and we have 3 choices for the burger. Either you have a regular burger, a cheeseburger, or a bacon burger. So if we're going to consider that, we have 3 choices. For every choice of a burger, we can actually pair it with 3 side dishes, namely onion rings, mashed potato, or fries. This can be matched with a regular burger. Same thing with the cheeseburger, can be matched with the 3 as well, and the bacon burger. Now, if we are going to do that, then we can order a regular burger, an onion ring, a mashed potato, and fries. We can also do the same for the cheeseburger. Order any of the 3 side dishes. As well as the bacon burger, we can order any of the 3 side dishes. And for every pair, we can actually have a choice of either a soda or an iced tea. Let's do the first one. We can order a regular burger, an onion ring, and we have either a soda or an iced tea. Same thing with the other choices. We can actually have either a soda or an iced tea. Then we can order a regular burger, a mashed potato, followed by a soda or an iced tea for a drink, same as with the fries. And the cheeseburger, onion rings, then we can have any of the soda, the cheeseburger and mashed potato, any of the soda, fries and the cheeseburger, any 2 of the soda, as well as this. We also have that choice. And the last would be bacon burger, fries with a choice of soda or iced tea. So all in all, we have 18 ways. To answer the previous question, what do you think is the chance that a random stranger will order a regular burger, a fries, and a soda? That would mean ordering a regular burger, a fries, and a soda will actually comprise 1 meal out of the 18 meals that we can have. Therefore, the answer would be, what's the chance that an individual will order a regular burger, a fries, and a soda is 1 out of 18 ways. Let's go further with our discussion. What if there are follow-up questions? In how many ways can one order a meal? Definitely, we have 18 ways. Let's refer to our table first. How many meals can be ordered with a bacon burger? There are 6 ways that we can do that. Definitely, there are 6 ways. The thing is, we cannot always look into the table or the tree diagram. What if the choices will be of bigger number? It will be difficult for us to use the tree diagram. That's why we can actually use the principles of counting here. We have a choice of burger, a choice of side dish, and a choice of drink. So in letter A, to be able to answer this, we know that we have 3 choices for the burgers, 3 choices for the side dishes, and 2 choices for the drink. We are to have this number of choices. Definitely 3 times 3 times 2, we can have 18 meals. So there are a total of 18 meals to choose from. That's why the answer in letter A is 18. Let's go to letter B. How many meals can be ordered with a bacon burger? It says here that there are 6 ways, but how is that possible? Remember, if it's a bacon burger, we don't have other choice for the burger but just the bacon burger, so we have 1 choice. How many choices do we have for the side dish? There's no classification, so we have 3 choices for the side dish, as well as the drinks, so we have 2 choices for the drinks. That's 1 times 3 times 2. There are 6 meals that we can have or that we can form having a bacon burger on it. So how many meals can be ordered with a cheeseburger. Same thing, there's only one burger and that's the cheeseburger, so we don't have other choice but one for the burger. But there's no classification for the side dishes, so we have 3 choices for the side dish. And we have how many choices for the drinks? We have 2 choices for the drinks. Multiplying that 1 times 3 times 2, that's 6 meals. There are 6 meals with cheeseburger on it. Letter D. Let's answer letter D. So there are 6 meals. How many meals with a cheeseburger and fries can be ordered? In this case, the burger should be a cheeseburger, so there's only one choice. There's also one choice for the side dish because the side dish should be fries. So, one choice. Times, how many choices do we have for the drinks? No specification, so we have 2 choices. That's why it's 1 times 1 times 2. We have 2 meals that contains a cheeseburger and fries on it. And last, how many meals with a soda can be ordered? If it's a soda, let's focus on the drinks first. The drinks should be 1 because it cannot be iced tea. It's just soda. But we don't have specification for the burger and the side dishes, so we have 3 choices for the burgers and 3 choices for the side dish. That means we have 3 times 3 times 1. The answer is 9 meals. There are 9 meals with a soda on it. So 9 meals. There are 2 meals. Okay, now what is the chance that a person will order a bacon burger? Since there are 6 out of the 18 meals, I'll change this to meals, okay? So that will be consistent. Meaning with the given choices of burgers, side dishes, and drinks, there are actually 18 meals in all. So the chance that a person will order a meal with a bacon burger is 6 out of 18 or 1 out of 3. Yes, okay. Same thing with what is the chance that a person will order meal with a cheeseburger. So that's also 6 out of 18 or 1/3. What is the chance that a person will order a meal with cheeseburger and fries on it? The answer will be 2 out of 18 or 1/9. And last, what is the chance that a person will order a meal with a drink of a soda? The answer would be 9 out of 18 or 1/2. So these are the possibilities of the meal to occur. Now, these possibilities is what we call probabilities. But before we delve on discussing probabilities, let's recall first the basic terminologies that we need in order to master the skills in probability. We need to know what an experiment is. An experiment is any activity which can be done repeatedly under similar conditions. The experiment in statistics is different from the experiment in science. In science, you go to the laboratory and you perform your experiment, correct? In probability, an experiment is something that we repeatedly do, an activity that we repeatedly do, like tossing a coin or throwing a die. Another thing is an outcome is the result of a trial in a probability experiment. When you perform an activity, example, you flip a coin and it turned out that the result is a head. That result is what we call an outcome. So an outcome is the result of a trial in probability experiment. Now, before performing the activity, you already have something in mind that the result will either be a head or a tail when you toss a coin. So, though the head and the tail, all the possible outcome is what we call sample space. Sample space is the set of all possible outcomes of a probability experiment. Just like when you're going to toss a coin, head or tail, throw a die, that would be a possibility of having 1, 2, 3, 4, 5, or 6. Then that's the sample space. And last would be an event. An event consists of the outcomes of a probability experiment. Example, when you toss a coin, getting a head is an event. When you throw a die, getting a 2 is an event. So I hope that's clear with you, but we discussed this already when we discussed fundamental principles of counting. So what is probability? Probability is a measure of certainty and uncertainty that an event will happen. Okay, the probability of an event is denoted by this symbol. It's either, example is either you get probability of getting a head, or we can say probability of getting a 3 when we throw a die, probability of getting a head when we toss or spin a coin, things like that. Those are the probability or the possibilities of getting certain outcome from an event. Okay, there are 3 types of probability though. The first type is what we call subjective probability. It uses a probability value based on an educated guess or estimate, employing opinion. I think if you study hard, there's an 80% chance that you will pass the test. That's an estimated or an educated guess. Since it's a little dark today, I think there's an 80% chance or there's a 70% chance that it will rain. That's an educated guess. It employs opinion on certain thing to happen. The next type of probability is what we call empirical probability, which relies on actual experiences to determine the likelihood of outcome. It is also known as experimental probability, which refers to a probability that is based on historical data. For example, 10 trials in rolling a die, I tally all the trial. For instance, in the first trial, the result is a head, the second is a head as well, the third is a tail, the fourth is a head, the fifth is a tail, the sixth is a head, the seventh is a head, the eighth is a head, the ninth and 10 is a tail. Okay, so if I'm going to identify the frequency of occurrence based on the 10 trials that I have 6 heads and 4 tails. So that would mean that the chance that the result is a head is 6 out of 10. 6 times that the head appeared out of the 10 trials that I have. So that's equivalent to 3/5. As well as the result for the chance that a tail will come out. That would be 4 over 10 because I had 4 outcomes of a tail out of the 10 trials that I had in the experiment. So that would be 2/5. This is how empirical probability is actually acquired. So I have to do the actual date, or I have to do the actual experiment, or I have a data that will verify the chance or the probability of that event occurring. Yan. The next probability is what we call the classical probability, which uses sample space to determine the numerical probability that an event will happen. It is assumed that the outcome in the sample space is equally likely to occur, meaning the items in the sample space have equal chance of occurring. Example, in tossing a coin, the sample space are getting a head or a tail. That means there is an equal chance of occurring of a head and a tail. We have 2 possible outcomes. So the chance that a head will come out is 1 out of 2. And the chance that a tail will come out is 1/2 as well. This is what we call the classical probability. So we make use of the sample space on which each item of the sample space is equally likely to occur.
This had been a great learning adventure. So, see you next time on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!